Welcome to the Math Record. For the first week of our April whatever class, we're going to be covering something more algebraic, how to convert between integers and infinite fractions, or continued fractions. So what is a infinite or continued fraction? Well, basically, it's going to be like a fraction that repeats over and over again. So let's say we have something like 2 over 1 plus 2 over 1 plus 2 over 1 plus 2 over 1 plus 2 over, right, etc. And this goes on for infinite amount of times, right? So it kind of follows this pattern. So let's first, if we're finding the conversion between integers and infinite fractions, let's first find out how to convert from infinite fractions to integers first, and then we'll do the reverse process. Okay, so how do we find the integer version? What is this amount in integer? Well, we have this as an x, right? It's not always going to be an integer, but I'm just going to say as a general case for integer, because I chose an integer version. So if this is 2, right, we have a 1 plus. So why did I put an x equals here? And the reason we set this equals to x is that if we see it's repeating, then we can substitute a part of it that's repeating and then kind of solve it later. So what I mean is that where does this part repeat? Well, we have this entire thing. It's the exact same as this entire thing, right? And it's also the same thing as this, and this. It doesn't look like it because it's getting smaller, but if you imagine this goes on infinite amount of times, right, and it gets really, really big, it kind of looks exactly the same. So what it does is that we have a 1 plus, so this part is going to become our x, and that's also still equal to our overall x, right? Because it's exactly the same thing. So now we have x times x plus 1, so 2 equals x squared plus x, and then we subtract 2 from both sides, so x squared plus x minus 2. So that means 0 is equal to x plus 2 and x minus 1 factored out. So that means x equals negative 2 or x equals 1. And x is not going to be negative 2, and that's because this fraction is a positive divided by a bunch of positives, right? So a positive divided by positives is always going to be positive. So it can never be a negative. So it can't be negative 2. So the only one that makes sense is x is equal to 1. So that means this all converges if you do it infinite amount of times, right? Infinite amount of this repeated pattern, we have 1. Okay? So we now know how to convert from an infinite fraction to an integer in generally. Sometimes it could be a fraction. So now how do we do the reverse version? How do we go from an integer to a infinite fraction? Well, what we could do is that instead of using 1 and 2, we could use a general case. So let's say we have a over, let's say, b plus a over b plus a. I'm not going to write it too many times because actually let's do it one more time. B plus a. Okay, so I'll do only 4 times because I think you get the general pattern. And we're going to set the equal to x. Okay, so now this is going to be our general case, and now we're going to derive a formula of how to do this. So where do we repeat it again? Well, we repeat it right here. So we're going to substitute our x in there. So b plus x is equal to x. And now we multiply both sides by x plus b, so it be x squared plus bx. So 0, and then minus a, so x squared plus bx minus a. And then we'll use the quadratic formula. So then negative b plus b squared minus 4ac. Just to make sure our b and our a in this case is not the same thing as our quadratic formula, a, b, and c. So then I just use really bad variables, but you could just follow along, it makes sense. My b squared minus 4a, a is our 1, and our c is a negative a over 2a, and our a is 1. Okay, so this all simplifies out to negative b plus b squared. A negative times a negative is positive. So negative 4 times 1 times negative a is plus 4a. So this one is plus 4a all over 2. And this is all equal to our x. So why do I choose plus here and not minus? Well, it's the same case as when we did our example from our conversion from infinite fractions to integers. And the reason is because, right, it cannot be a negative. If this is a negative, then a negative with another negative makes a negative, which is not possible because x cannot be negative. So for this to be possible, that means a this portion has to be compositive because a positive plus this negative would make it a positive. So how do I know this is going to be bigger than this number? Well, that's because square root of b squared is b, but this one's b squared plus 4a, right? So this has got to be bigger than b when it takes the square root of. So now we have that version. So let's kind of delete all this work because we don't need it. And also I need room. Okay. So we have this. So what does this equation kind of tell us? Well, this kind of tells us that A and B has infinite amount of possibilities. So let's say you want to have 2, and we want, actually, yeah, let's use 2. If we use x is equal to 2, how do we put, what values of A and B is going to work together to make this 2? Well, actually, based on this equation, it's not just going to be a value for A and a value of B. It's actually going to be infinite amount of possibilities. And that's just because we have A and B working together in this equation to make a variable x. So think about this as an equation, right? So how do we do that? Because this kind of looks a little bit ugly, right? We have A and a B here. How do we work with this together? Well, let's think about x. If you think about a general case where we have a number, right? X is already given to you because that's the number you choose. So that's going to be given. And if this is going to be an equation, we got to choose an input. So let's say B is our input. Okay. And the reason I chose B as our input is because B is right here. So B is going to be our smaller number. And then A is going to become our bigger number that we have to find later, right? It's always going to be easier to find a bigger number later on. So this A is going to be our output. Okay. So now we just have to find all these numbers in terms of each other. So multiply both sides by 2. So we have 2x is equal to negative b plus b squared plus 4a, and then plus b, right? Equals square root b squared plus 4a. And then we square both sides, right? And then we have, sorry, 4x squared plus 4bx plus b squared is equal to b squared plus 4a. Cancel out like terms, so we cancel out the b squared. And now we can divide by 4. So that'll be x squared plus bx is equal to a. Okay, and that's why I have b as going to be our input. So we have b as an input that we're going to plug in, and we're given x. So then we could plug in all those numbers, and we're going to get our a. And that's why it's going to be called our output, right? An input helps us get our output. So our a is going to be equal to x squared plus bx. Okay, so let's try an example. So let's try an example with number 5, right? So let's say we want to convert 5 to an infinite fraction. So x is going to be equal to our 5 because that's what our given is. And now we're just going to choose a b. So we could choose any number. So even a number that's bigger than 5. So let's choose something like, let's say 7. Okay. So we don't know where a is. So we're going to leave that blank for now. So we have 7 plus some kind of number, right? Plus that where our fractions go on forever. So now we just follow this formula, right? What is our 5? Our 5 is, what's our x? X is 5. And what's our b? It's 7. So then our a is going to be equal to 25 plus 35, which is equal to 60. Okay, so let's erase this. So we know it's 60. So it's got to repeat a and b respectively like this. It's 60 and 7. So 60, 7 plus 60 over 7 plus 60 over etc., right? It goes on forever. So let's kind of check if that works. 5 equals 60 over 7. Remember, this part just comes out as 5. So that's 60 divided by 12 is equal to 5. So that's true. So we know that our example is true. So that kind of works out really well. So that is how you would generally be able to do it. So let's do one more thing. So why does this work? Well, let's use our example. A over b plus x equals x, right? So if we substitute our a in here, we have x squared plus bx over b plus x is equal to x. Now just shoot out our x. And now you can see why this comes out as equal to x, right? Because we have, I just switched the places of b and x on the bottom. It's still the same thing. So we cancel out both of these on the top and bottom. So x equals x. And that's the reason why it kind of makes sense. Because instead of like doing all that work, uh, which we were able to prove, a more logical way to think about it is that if A and B is going to be infinite amount of possibilities, then what we could do is that we could have A in terms of x and B, right? So we could just have this part as B plus x. So they'll cancel out with each other, but we need an x in there, so we put an x on top, right? So then b plus x divided by p plus x is just 1. So x times 1 is x. And then we know a is going to be equal to this. So x times x plus b is just x squared plus bx. Exact same thing as this, right? So that's another logical way to derive it. So that's going to be our general formula to find a conversion between our integers and infinite fractions. I hope it was kind of interesting and view integers in a different perspective. And if you want to see more content like this, check out our other whatever classes. Thanks for watching.